Okay, so now let's start talking a little bit about polar coordinates. All right, suppose I want to reset this now, and suppose now I convert this to the polar axis and the polar grid, right? So here I have my polar axis, and here is the line pi over 2, right? And suppose now I am given r. Okay, suppose you're given r, and suppose you're also given theta. Okay? Now, how would I find x and y if I have r and I have theta? So look at this one. If this is a right triangle, and if you know this theta and if you know this side, how could you connect those to x over here? How is x related to this angle and the r? How could you find it? You can use cosine, right? Cosine of theta is equal to x over r. So then what would x equal to? R cosine theta. All right? Now, what about this y? Right? How can you write y in terms of r and in terms of theta? Well, that's the sine, right? Sine of theta is equal to y over r. So y is r sine theta. Where else did we use that stuff? In what chapter? 5, and where else? Just recently. What does that? Chapter 8 in terms of what? Vectors. What was this of the vectors? The products, the components of the vectors. So if r was the vector, the x component was r cosine theta, and then the y component was r sine theta. So it's the same exact thing. So now this x component is r cosine theta, and this y component is r sine theta. How quickly we forget, right? So if I want to go to that, going back, if I want to go to this point here along horizontal and vertical, how much do I go across? R cosine theta. How much do I go up? R sine theta. So now, if I wanted to write that point P in terms of x comma y, well, I could just say that it's r cosine theta, r sine theta. Okay? So now, exactly. So now, if I'm given polar coordinates and I want to go to rectangular coordinates, that's all it is. If you've got r and theta, how do you get x and y? Well, right here. R cosine theta, r sine theta. That's it. So here we go. Here is an example. I've got a coordinate here given in polar coordinates. So I have an r and I have a theta. And I want to convert this to x and y. Well, how can I relate r and theta to x and y? Using trig, right? So now, right. So before we get to that point even, let's just visualize what this looks like, right? If I have a radius of 2 and an angle of pi over 3, so if this is the polar axis, pi over 3 is right about here, right? So that's what it looks like. This is a distance of 2, and the angle is pi over 3. So you see where, in terms of the polar axis, my point lies, right? Which coordinate is that most consistent with? Which coordinate? Which quadrant? Quadrant 1, right? So let's now convert this. So x is r cosine theta. So this is 2 cosine pi over 3. We know what cosine pi over 3 is, don't we? It's 1/2. So x is 1. All right? And then y is equal to r sine theta. R sine of pi over 3. R was 2. So that's 2 times, what's sine of pi over 3? Root 3 over 2. So y is just root 3. So now my coordinate is 1 comma root 3. Now let's think about whether or not that makes sense. How much is root 3 roughly between what and what integers? 1 and 2, right? So let's say it's like 1.4. It is. Let's just, okay, it's 1.4. So now my coordinate is 1 comma 1.4. Is that consistent with this quadrant 1 point? Yes. Okay. So you see how you could figure that out. Okay. Now, let's take a look at this one. Now we have -5 and 45 degrees. Let's get a visual. If this is the polar axis, 45 degrees would be right there, right? But if it's -5, then which way is it pointing? Down to which quadrant? 3. Okay, so it's like -5 that way. All right. The absolute value here is 5, right? That distance. So that's where we're at. So now, this is the big picture. When you mechanically put in numbers, x cosine theta, x, r cosine theta, r sine theta, you don't want to just, randomly get an answer and not know if it makes sense. So for the x coordinate, it's going to be -5 cosine theta, -5, and theta is 45. Root 2 over 2, right? So x is just -5 root 2 over 2. So what's y? -5 sine 45, -5 root 2 over 2. So my coordinate is -5 root 2 over 2, -5 root 2 over 2. Does my answer make sense?
Yeah, they're both negative.
They're both negative. That's in the third quadrant. Does it make sense that it's the same unit, that it's the same amount, x and y? So basically my x is going -5 root 2 over 2 in the negative direction, and then 5 root 2 over 2 in the down direction. Does it make sense that those two red lines are the same distance?
Yeah.
Why? Because it's a 45-degree angle, so that's an isosceles right triangle. Do you see how it's absolutely consistent, right? You see how the math just works in such harmony, right? Okay, so it's like a marvelous thing, right? Marvelous. It just makes me so happy. So now let's see if we could go backward. Now if I have rectangular coordinates like 3 comma -2, can I go to polar coordinates r comma theta? All right, so now suppose I know x and I know y. If you are given x and y, can you find r? How could you find r? It's the Pythagorean theorem, right? So r squared is equal to x squared plus y squared, and then r is just the square root, right? That's it. You have x, y, and they're sides of a right triangle. Of course you could find r. Okay? We need r comma theta, right? All right, we just figured out a way to find r. Now I need theta. Okay, so what do I have? I have this setup. I've got a y, I've got an x, I need a theta, right? Right triangle right here. So how can I connect the x and the y to one another? And if I want to find theta, trig has to come in somehow, right? So which trig function will give us theta?
If you have x and y,
Then tangent, right? So tangent of y and over x, I'm sorry.
negative.
Yeah. Tangent of theta is y over x, right? So if you want theta, it's inverse tangent of y over x. All right? Yes.
If you find r, could you use the sine equation or just change? Strictly use what you were given and then
So the thing is, you have rectangular coordinates. What we're talking about here is you have rectangular coordinates.
Yeah.
The only two things you have are x and y.
Yeah, I'm talking about after you've done Pythagorean theorem and solve for r, can you use cosine or sine?
Sure.
Sure.
We normally don't. We always, just like this is how we define it. We define it using what we're given, but of course, all right? Okay, now, Here, when you find theta, right, from the inverse tangent, always remember that you're going to get, and when you put it in your calculator, you're going to get what looks like a reference angle. So for example, 23 degrees, negative 23 degrees. And now it's up to you, the human being versus the calculator, to figure out which quadrant does my angle fall in. Does 23 degrees make sense? Do I have to add 180, subtract from 360, and so on and so forth? That's all stated here, right? But you know what I say to that? Do not memorize that stuff. This is where you, the human, come in and you reason it out. Okay? All right. So, let's find, okay, so here we're given rectangular coordinates and we want to find two pairs of polar coordinates for each point. All right? So, what I have here is x and y. What I want is r and theta. Okay? And I want two pairs. So let's just do one and then we can go from there and find the other one. Okay, so if you're given x and y, r is the easiest. It's just the square root of 2 squared plus 4 squared. Yes, it's negative 4, but we're squaring, right? So r is root 20. Which is 2 root 5, and that's roughly 4.47. I'll just give you that one, okay? Now, what I also want is theta. So theta is the inverse tangent of y over x. Now, can you use r? Okay, yes, you can use r. Mathematically, yes, you can use r, but two things. What if you got r wrong? Then it's all wrong. Okay. Also, yeah, then it's going to be the sign, which fine, but then, you know, there is like, what if, like, so don't use the rounded one, okay? Just be careful about that stuff. Okay, so inverse tangent of negative 4 over 2. Okay. Now, go ahead and put that in your calculator in radian mode. Radian mode. Sure, it's the same.
Okay.
So I'll tell you. So it's negative 1.11. Okay. This is in radian. Okay. Where is negative 1.11? So if I'm on the unit circle here, right? And in radian mode, we know this is 0, pi over 2, pi, 3 pi over 2, and 2 pi, right? What's the value of pi? 3.14 in radian, right? So that's 3.14. So that's 3.14 radian right there. So then half a pi is 1.57 radian, right? Half of 3.14 is 1.57. So where does negative 1.11 lie? In what quadrant? The fourth. Okay, so 1.11, yes, it's right there. Okay, 1.11 would be here. But negative 1.11 lies right there. Okay, now, does this make sense? What's my coordinate? It's 2 comma negative 4. Does it make sense that I'm in the fourth quadrant? 2 comma negative 4. It so makes sense, right? Okay, so, yes, 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 of course you can. So here is my, okay, so I'm going to call this theta 1 because I'm going to come up with 2 of them. So now r comma theta, take a look. It's going to be 4.47 and negative 1.11. This is my first coordinate. Now I'm going to have to come up with another coordinate. Yes?
Would you leave the r in 2.5 or would you rather do that?
Either.
Okay.
Either. Yes.
Could you add 360?
Okay, so now we have several options. We can, the easiest is add 2 pi, right? Because we're in radian, add 2 pi. So theta 2 will be negative 1.11 plus 2 pi. That's the same as negative 1.11 plus 6.28. And how much will that be? 5.17.
Is the only option to make it negative and then add an 80?
Right.
Make
Yes,
R
correct.
and then add an 80?
Correct. So now I have 4.47 and 5.17. And let's see if that makes sense. That angle makes sense. So if I'm going this way, it's 3.14, and then 5.17 will be somewhere over here because it's 6.28 all the way there. So you see how I landed in the same spot. Cool? Very cool. The other option, yes, this is why, you know, we did all that stuff in section 1. You can make r negative, but add pi, and so on and so forth. Okay? Because I asked for 2 pairs of polar coordinates. All right. So here's another one. Same situation. This is this is x and y, and I want r and theta. So again, my r is going to be the square root of 1 plus root 3 squared. How much is that? Root 4, which is 2. Okay, because it's root 3 squared. So theta now is inverse tangent of negative root 3 over 1. And look, when you put it in your calculator, how much is theta 1 here? Negative 1.05. You switch to radian? Yeah. Good. Negative 1.05. So then theta 2 would be that plus 2 pi. And how much is that? More. 5.23. Yeah, so I have 2 and negative 1.05, 2 and 5.23. Okay. All right. Now, if I can convert a point, a coordinate point, back and forth between rectangular and polar, then I should be able to do the same thing with an entire equation, right? Okay, so we've been graphing equations here. What was the equation of a circle? R equals a cosine theta or a sine theta. So I could graph a circle that way, but we've been graphing circles in rectangular coordinates forever. What was it in? X squared plus y squared equals r squared. How else can I draw a circle? It could be, you know, okay, so take a look at this one. Take a look at this one. I have a rectangular equation of a circle. X squared plus y squared equals 9, right? It's x squared plus y squared, and this is the square of r. So basically, this is a circle centered at the origin with radius 3, right? Right there. I could either do all of that, or I could just say r equals 3 and plot all of the points, the set of all points that are 3 units away from the origin, and I get the same graph, right? So those two mean the same thing. Take a look at this one. The rectangular equation of this line is 2x minus 3y equals 6. Look at the polar equation. Believe it or not, when you graph it, that's what you get. So part of this lesson is to convert back and forth. All right, so if we want to convert from rectangular equations to polar, always keep track of what it is that you're doing. So we're going from rectangular to polar, all right? What you want to do is you want to get rid of x and you want to get rid of y. Well, what is x? X is the same as r cosine theta. So you have to replace x with r cosine theta. And you have to replace y with r sine theta. So this is the thing. When you get more and more comfortable between these two worlds, you just sort of know, like in your mind, when somebody says x, in your mind you think r cosine theta, right? This is where, this is why we do vectors before we do this, because I feel like, we learn it in like bits and pieces over there, and now it's just it forever. So I always say this. Right now, you're learning math in bits and pieces, and you learn functions, and then you learn vectors, you learn matrices, you learn polar coordinates, and you feel like these are like isolated, little parts of one another. Only as you go higher and higher and higher do you see, when you zoom out, that all of these things are part of like one big math thing. Like that's like math nirvana. Like all of these things are like connected to each other, right? Polar coordinates, vectors, matrices, like these are all like one thing. So don't treat these as like separate things. X is just r cosine theta. That's just what it is, right? R sine theta is just y. Okay? So once you replace that, then you have to still simplify using algebra. Oh, and trig identities come back as well. Okay? Yeah. Because where you have trig, you have identities. Okay, so, here's the fun part, guys. Okay, we have an equation here in rectangular coordinates. First of all, what kind of equation is that? What is that an equation of? A parabola, a line, a circle. How do you know it's a circle? You have an... Right, so x is squared, y is squared, but also x squared and y squared have the same coefficient, right? So when you square this, you get x squared and y squared. If it was x squared and like 2y squared, it could be an ellipse, okay? So you know it's a circle when it's x squared and y squared and they have the same coefficient. Okay. Now, we gotta go to polar form, all right? So we're gonna replace x with r cosine theta plus 2 squared. So far I've done no math. Plus y is r sine theta squared equals 4. Okay? Okay, now let's do some algebra. I have to square this, so I'm going to get the first term squared is r squared. No, don't do that. R squared cosine squared theta, right? Plus, what's the middle term? 4r cosine theta. So this times this times this. 4r cosine theta plus 4. Plus, now I got to square this guy, and I get what? Equals 4. Look at what I have here, guys. Plus 4, they go away. Huh? What about sine squared? You can. You know what else you could do? Let me just swap the order here. R squared cosine squared theta. And you know what? I'm going to write this one next. Just rearranging. R squared sine squared theta plus 4r cosine theta equals 0. I just rewrote the same thing in different order. Can you? You can actually factor out an r squared. Let's factor out an r squared. Only on those two. Only on those two. So cosine squared theta plus sine squared theta, how much is that? It's 1. Plus 4r cosine theta is equal to 0. So all this is 1. So now it's r squared times 1. So it's just r squared plus 4r cosine theta is equal to 0. Now, so the thing is, you can't have, r squared and r. In the end, you have to solve all this for r, okay? So you have to, like, simplify. So divide by r, divide by r, divide by r. Now I have r plus 4 cosine theta is equal to 0. And what's r? What equation is that? That's a circle. That's a circle. Because, oh my goodness. Oh my goodness. Wild. Because look. R equals a cosine theta. That's a circle. That is a circle. But now, the left, okay, so R equals a cosine theta. It's horizontal, and because a is negative, it's on the left-hand side. Let's see if that makes sense. Let's see if that makes sense.
It's gonna make sense.
It's got to make sense because it's math. It's got to make sense. So take a look here. If it was just x squared plus y squared equals 4, it would look like this. But now it's x plus 2 squared plus y squared equals 4. What does that plus 2 do? Move it over to the left 2 units. How much is the radius? 2 units. So if I move, okay, so this has a radius of 2 units. And if I move that circle to the left 2 units, what does it look like? Oh my God, it looks like that. Oh my goodness. And what does negative 4 cosine theta look like? It's a circle right here, length of 4. Length of 4, what's the length here? Radius of 2, diameter of 4. Tell me that's not like the most wonderful thing you've ever seen, right? How amazing is that? Yeah, that's awesome. So, yeah, no, it's fine. So this is a reflection. The negative is a reflection around the polar axis. And the 4, it says, that there is a diameter of 4. Yeah, it is. Huh? I know. Okay, so that's the thing. Like, there's so much good stuff here. That's why I always keep saying, like, starting with chapter 8, like, don't miss any school because, like, it's all the good stuff. Okay, so.
Yeah, that one failed.
Okay, so. Okay, let's do another one. So here I have 2xy equals 4, and I need to change them and make them what? And r sine theta. Good. So let's just get a feel for what this looks like. If you solve this for y, what does it look like? 4 over 2x, which is 1 over 2x, right?
2 over x.
2 over x. Now, what does 1 over x look like? What? It looks like this, right? The reciprocal function, right? It's 2 over x. So basically, x can't be 0 because it will be undefined. And there is no value that would make y 0 either. So that's what it looks like, okay? Now, thank you. So here we have 2 times x times y, right? Because we now know x is just r cosine theta and r sine theta. Okay, now, so listen. What I've done here is I've put one example of, of the of all the different types of like tricks you would have to do. So one trick was up there, we had to divide through by r. So now look at what happens here. We can't divide through by r in this case because we did it over there because it was 0 on the other end. So what we're gonna do, let's just combine the r's for a minute. I know you want to, but not yet, because look at what's gonna happen now. 2r squared sine theta cosine theta is equal to 4. Okay, now I'm going to rearrange the r squared and the 2 because I can do that. So I'm just going to write it as r squared times 2 sine theta cosine theta. I could do that, right? Right. Huh? Yeah, I know. So it's the practice. I know. What's 2 sine theta cosine theta? It's an identity. It's equal to what? It's a double angle identity. You know what it is? We don't have too much time. It's sine 2 theta. Remember? Sine 2 theta is 2 sine theta cosine theta. So this is r squared sine 2 theta is equal to 4. Okay? Now, we've seen lemniscates, right? Which are r squared equal to something. So we know that it's okay to get an r squared. So let's just solve it for r squared. It'll be 4 over sine 2 theta. Okay? Believe it or not, we're pretty much done. Yeah. Normally, we don't leave it as 4 over sine. It would be cosecant of 2 theta. So r squared is 4 cosecant 2 theta. I know. Okay? Huh? No, that's it.
Like, it's the time when we find out that this is actually something.
Which one?
Like that one.
So this one, if you graph it, and I'll show you guys this tomorrow, if you graph it, you actually get that. So tomorrow we'll do some graphs with the polar stuff as well. Okay, let's do this next one because I love this one. What kind of equation is this? An equation for what? A parabola. Right? Y equals x squared. That's like the classic parabola, right? That's what it looks like. Don't worry about the graph yet today. So now I know what y is. It's r sine theta. And I know what x is. It's r cosine theta squared. Okay, let's square these things. And that's what we get. Now, what can I do here? Divide by r. You see how you could do it now? When you could divide through by r? So divide by r, divide by r. So sine of theta is equal to r cosine squared theta. Now you're going to divide by cosine squared theta. See? This is why when we are doing trig identities, 5.1, this is why I don't let up, because you got to get used to it then. So right now, the second time, it's not as bad. So now, what do I have here? I have r is sine of theta over cosine squared theta. We try to eliminate the fractions as much as we can. So what this is sine of theta over, I have cosine squared, which is cosine times cosine. So I could write it as cosine times 1 over cosine. Yeah, it will be eventually. Do you guys see why I did this, how I did this? Okay? This is so exciting. So then r is equal to tangent theta secant theta. Okay? All right. So now, for homework, page 557, we're gonna go up through number 33 here. So this, due Friday, whatever the date is, March 29. Yes, please.
Tomorrow.
Yes. Okay.